then line, the simple one. Shortcut is L. First point, second. Just you get out. Means when you are in profile tool, whenever you draw a line, the line still continues to draw further line, right, or arc. But in line, you can go. Just press escape and get out of it. Whichever command you need, you can get out of it by using escape, right? Then arc, right? There are again two types of arc, that is by 3 points and then center and end points. Okay, first we will look at 3 points, arc by 3 points. First we have to specify this start point, then end point, and then the center point. Center or center arc point, you can say. Just by specifying 3 points, you can draw. But starting is first point, second point, and third point, like this. Okay, this is arc. Next is by center and end points, right? Here you have to specify the center, then the start point, end point, right? Again I will show it to you. 1, 2, okay, 90-degree arc. You can draw as per your requirement, you can draw. Okay, next, that is spline, right? Spline is continuous line, right, which is tangential, you can say, to the previous point. Right? 1, 2, 3, 4. You can see this point to this point is smooth. We can't say tangential at every point, right? But it tries to maintain it tangent. Okay. You just click on point, various points will be generated. Okay. This line, basically, it is very rarely used, but in some sector of industry, the spline is majorly used, right? There are exceptional cases where spline is used for shape design, turbine blade design, or propeller or fan blade design. So, as we can see, the blade curve is very smooth. So, by using line curve, it is not possible to draw a smooth line over there. So, in that kind of area, spline is being used, right? Constraining spline is also quite difficult, because if you have to give fully constraint to it, you have to specify the dimension of point in both of the direction, that is x direction as well as y direction, right? So, how many number of points you have into 2, that much dimension you have to provide for fully constraining the spline, as well as the position dimension of spline from origin. Okay, so this was about spline. Point, simple, right? Just click, you will get point. But if you have to specify the point in specific location, right, then here you can go in point dialog. Just click over here. Here you can specify the coordinate where you have to specify the point over, but you don't know the coordinate of it. So then what to do? So you have various kinds of tools over here. That is cursor location, which we performed just right now. Existing point, right? Existing point means previously there is a certain point over there. You have to plot the new point in that same location. That is existing point. For example, this one. So you can see here point is not there, so it is not highlighting, and here point is there, it is highlighting. So as you click over there, the coordinates of them get traced over there. Okay, this is existing point, end point. For example, you need end point of this, but if you require this end point, then you need to click near to that end. Okay, control point, you can see. Control points means usually the center of it. Okay, midpoint you can say. Okay, here point will be plotted. point is there. Okay. There are more options over there in point dialog box. Intersection, where two parts are intersecting. Let me see. Where is the intersection? Yes, here is also there, but I will extend it. So now you can see this line is intersecting this curve. So in point dialog box, we can select intersection, this curve and this line. Intersection will be computed. Okay, point will be plotted. Similarly, there are various tools again in point dialog box. Right? Arc, sphere, arc, ellipse, sphere, center point will be plotted. Right? And various another also there. You can just explore them, or if you find any difficulties in the furthermore point dialogs, you can just mention them in Q&A section. I will put them for you, or I will try to explain them. Right? Majorly, only 2-3 types of them are used, but if you require, you can just ask me. I will just explain it to you. No problem for it. Okay. Moving forward, we will go to the operation tools now. That is fillet and chamfer. Right? Fillet and chamfer. It is very important while working with designer. Right? As we perform various kinds of product development or existing product improvement factors, chamfer and fillet plays a vital role in it. You might be knowing, but for someone who don't know it, we will discuss them shortly in brief. As we can see, every component in practical condition does not have any sharp corner. Whichever component you can see with your eyes, maybe it would be of metal or plastic, it is not sharp usually, right? So in engineering, we have learned a term that is called as stress concentration. Wherever there is a sharp corner, right, so there is a chances of getting stress get concentrated over here. So to avoid stress concentration and smooth flow of stress, usually chamfers and fillet is used. Okay, so now we will look to chamfer and fillet. Okay, fillet. What is fillet? Right, providing a circle or radius to a corner. Right, this is fillet, or you can also this called right. Providing a circle or radius to a corner. Right? This is fillet, or you can also this called as edge radius. Okay, edge radius. You can just provide the radius to it, and circular region will be computed. Right? There are two types of fillet in nature. You can see this one and this one, and another. Draw a profile over here. Fillet. Again, this edge and this edge. I'm selecting this. Right. So this gets concave and this gets convex. Right. So here you have to add a material. For example, you won't be able to imagine this. Now here we can compare that. You can say this is the solid part. Here this is the inner edge. You can say this is the outer edge. If you give fillet over here, this is called as edge fillet, and if you provide fillet over here, this is called as edge round or round. Fillet and round. right? Usually this doesn't have problem, but sometimes we have to concern this with the manufacturing team because tool might have some problem while reaching to it, right? But this kind of fillet doesn't have any problem. You have to specify this radius over here and you can specify it. Usually it is tangential at both sides. Next one, it is chamfer. Similar kind of work it does like fillet. Here you have to select two lines, first line, second line, and here the inclined line will become. As I have selected symmetric over here, that is 300 by 300, right? So it will come. Here you can change it. If you have to specify angle and length, you can do 1, 2. Okay. Here you can provide distance and change the angle as per requirement. Okay. You can see. Okay. Asymmetric also you can give, providing it and giving the different dimensions. Asymmetric I have given, but the dimensions were same. So what I can do over here, so I'll just zoom in and just change this dimension to 700. So you can see asymmetric distance. As per the dimensions you have, you can provide any one of the chamfer. Okay.